Hello friends. So let's try to solve today one of the important Leetcode problem, that is Leetcode 54 spiral matrix. So this is a medium problem, but it is a good problem to solve. It has been asked in many companies, many good companies. Uh, so let's go and check this problem. Given M into N matrix and return all elements of the matrix in spiral order. So there are M number of rows and N number of elements in each row. So here, this is a 3 by 3. First example is 3 by 3 matrix, and 1, 2, 3, 4, 5, 6. These are the elements of it. And basically, they want us to traverse in a way, in circular way, semicircular way. 1, 2, 3, then 6, 9, 7, 8, 7, 4, 5. And here the traversal ends here. This in same way they have given one more matrix, that is 3 by 4 matrix, 3 rows and 4 columns. Here the traversal would be almost similar. The difference between the two examples, two test cases, is one is the 3 by 3 and number of rows and columns are equal. Whereas here the number of rows and columns are not equal. Where here number of rows are 3 and number of columns are 4. So 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, 6, 7. So at 7 it ends traversal, and you can see your output over here. So okay, let's solve it. Let's try to solve the problem. Yeah, let me full screen so that I can. So while solving the problem, I can see the intuition before solving the problem. Let's discuss that part. So basically, when we traverse from 1, 2, 3, 6, 9, 8, 7. So from 1 to 3, we are traversing from left to right. Whereas when we are traversing from 3 to 9, we are traversing from top to bottom. Whereas when we are traversing 9 to 7, we are traversing from right to bottom. Whereas in same case, if you think of 7 to 4, we are traversing from bottom to up. So one thing we can make out here, that we are traversing from either left to right, or either right to left, either top to bottom, or either bottom to left. So these are the four directions we are traversing, and that is helping us to travel in spiral order. Okay, so yeah, let's start coding it, and then we'll understand step by step. So here we know that, as we discussed, at least we know there are few things, constraints we need to think that. Uh, M is denoting the matrix length, means number of rows this M is denoting, and the N is the uh, length of the um, each row in the matrix. That is length of the each row, that is. And whereas number of rows, there will be at least one row, and whereas elements there will be maximum 10 elements in the each row, and the values of the elements will be either greater than -100 and less than or equal to +100. That will be the elements. So here in this traversal, value of the elements does not make any sense, because we are just traversing them. We are not manipulating or taking any decisions on them. So let's ignore them. So as we have discussed, we are traversing from left to right, top to bottom. So let's take variables. Left equal to 0. So let's take a right. So in this case, what would be the right one? The right one would be the matrix, and matrix of size. So let's take first row and then matrix size. This is the right one. Okay, let's take a top equal to 0, then int bottom equal to matrix dot size. Okay. So these are the two edges where we are starting our traversal. Okay. Then So one thing we can understand here, we are traversing from left to either left to right or either top to bottom or either right to top, left and either bottom to. So here the left is the smallest value and right is the highest value, whereas the top is the smallest value and bottom is the highest value. So one thing we can consider over here is left will be until what is the terminating condition for this while loop is left will be always less than the right value. And at the same time, right, if we consider right will be, top will be always less than or equal to bottom. So this is the base condition where this loop will end. Okay. So as we discussed over here in that, first iteration will be traversing from left to right. Left to right means let's consider left to right. Okay. Left to right. Okay. And we'll have a loop integer I equal to left. I is less than or equal to right. Okay. So one thing we missed here, we need to take -1 because the index is, we are starting from 0th index. So let's take size equal to -1. Okay. Then I plus plus. One more thing I missed here that we need to define resultant vector as well. Sorry. We want to return v result vector of type this. Okay. Now let's push element one by one over here. Dot push back. What we want to push back here? We want to push back elements from 1, 2, 3, left to right. One. We want to push these 3 elements over here. So matrix. And what is constant over here? Constant over is a row is a constant. Row is a constant means this will be top. Okay. And what is variable over here? Columns are variable. Columns are variable means I. We are placing I over here. Now we traverse the top line. Top line we have traversed already. We are making it as a top plus plus. Okay. Next iteration will be top to bottom. Okay. Okay. So here for int I equal to 0, I is less than or equal to okay, we are not making here 0, here we are making top, correct? Because we are going from top to bottom. Then I plus plus. Again, we will try to push. Again, we'll try to push elements. Now, here, while traversing top to bottom, what is the constant over here? Column is the constant. Column is the constant. So, column is the constant means variable is the row is. Row is a variable. Row is a variable means, and we reach to the right end. Right end. So, we are right edge is the constant over here. Okay. So, we have traversed top one right edge. Now, we need to traverse bottom line left to right. So sorry, right to left. Right to left. Okay. So again for loop for integer I equal to here right. I is greater than or equal to. Why it is greater than or equal to? Because we are already at the right. We want to minus 0. So we want to move from right to left. Then I minus minus. Okay. Okay, when we are moving from right to left, and what is the constant? Bottom is the constant here. Bottom is the constant, and row where bottom is the constant here. Bottom is constant over here, and I is variable over here. Okay. From here we are now moving from bottom to up, bottom to up. Okay. Bottom to up. Or int I equal to 0. Sorry. I equal to not 0. I equal to bottom semicolon. I is greater than or equal to top I minus minus. Okay. Here row is constant. Row is a constant. Here row is a constant, and here we are at the left edge. Okay. And I is column is variable over here. So one more thing I think we have missed here. We moved on top line. We have traversed top line. We plug incremented that. Uh, we traverse the top line. We traverse the left line. Sorry, right line. Here we need to make a right plus plus. We traverse the 369 this line. So we need to increment this. We need to increment right. Sorry, not increment. We need to decrement right minus minus. Okay. When we moved right to left, we have traversed the bottom line. So we need to minus bottom line 9 as well. Bottom line as well. Bottom minus minus. Okay. And we have traversed leftmost line. So left plus plus as well. Okay. Let's return. We use out. So we have already inserted elements. Let's okay. I think this has been successfully. Yeah. So one test case has been successful for 3 by 3. It has successfully. The one case that has been. Let's see what we have missed over here. So when we traverse from 1, 2, 3, 4, 8, 12, 11, 6, sorry, 11, 10, 9, 5, 6, 7. Okay, let's see what we've done here. I think we are very much close, 5, 6, 7, and the last is a sixth element is. So basically, I think again we are coming back here and so here it might be possible that top has already crossed and top is already greater than top is already greater than bottom. That might be the case. So let's check. Just add a bottom here, check here. If top is less than or equal to bottom, then only traverse here. I think it makes case here as well that when left is less than or equal to right, then only we want to move. So basically, when top is less, even though we have crossed top value here and right value here, and we are our high loop is at it not broken here. So we just wanted to check whether before pushing the elements, whether top is less than bottom and right is left is less than or equal to right. Okay, let's run it. Yeah, I think both of the test cases are successfully ran. Yeah, yeah, it beats near about 71%. So this is very good. Thank you so much for watching.